Hello everyone, this is Chris Bohr with week 8 creative video / neat video. For this time around, I made a Python program based on what I did for group project 2, which basically it modeled a person's basketball shot given certain data, and what I plan to do in this project here is ask for several variables such as your height when you shoot, your distance away from the basketball hoop, the angle at which you shoot, the speed at which you throw the ball towards the hoop, and if you want to apply backspin on the ball. More on that later. I guess I'll just kind of go over the code a bit. I borrowed some stuff from of David's programs in the other section, so I mean basically just designing the objects, keep it real simple: backboard, rim, basketball, right here. I'll go into that more. It's basically you can find out your this is basically all the information you need for your trajectory according to the Python program. You get the velocity and the x direction if you know the angle and the velocity component and the in both direct. I guess let's just explain that now. I'm not sure if I don't think we went over this in class, but basically if you have velocity in both along the x-axis and velocity over the y-axis, the motion or the position is going to change diagonally. So you could say you have a vertical component or velocity along the direction, pretty much just using the Pythagorean theorem, and you can just use trigonometry to find out the velocity in the x and the y. So once you know that, you can apply a vector and just simply give it a velocity along the x and y axis. And in regards to this project, we aren't going to use the z axis. So basically, the basketball shot's going to be perfectly aligned along the basketball hoop. So after you got all that, you set up your timer and everything. I set it to 30 seconds because first it's going to prompt you in a separate window, and then it's going to do the visual thing. I didn't want to go off right away. So I also try to incorporate rotations. I'm not sure why, but it's along the z-axis is the backspin. If you were to the flick of a wrist on a basketball shot puts a backspin along the z-axis. I thought it would have been x, but anyways. And so there's pretty much my code. It's very similar to David's bouncing ball code. Here's if it comes in contact with the ground, it's gonna slowly lose friction. It's probably not a true physical process into the real world, but there it is. If it's not in the ground yet, I mean it's still gonna be losing velocity due to gravity, or the earth pulling down on the ball, so minus 9.8, and this acceleration, so it's per second within the actual second. And then I've also set parameters up if it hits the backboard or if it hits the rim. And according to the USA Basketball site, it said a ball may not be pumped so that on its rebound it can accelerate more than 50% of its energy. So I'd say the resulting vector is only going to be half what it is in the opposite direction, hence negative, and hence why it's divided by 2. So I think that's pretty much it, and let me just show you how it works. Okay. Why are you doing this? Okay, there we go. So first you're gonna enter your height, and this isn't your like actual height. It's your height plus your vertical distance, and your hands are probably going to be a little bit above your head when you shoot. So I'm about 5.5 feet or a little bit more than that, and say I jump maybe around 1.5 feet or so, so my release point is going to be around 7 feet, which is 2.1 meters. Distance away from the hoop, let's say 17 meters, which is around the 3-point line. The angle which I want to shoot is going to be around 55 degrees, and that's pretty good. The speed at which I want to throw the ball in millimeters per second is going to be around, let's say 10, because you want your shot to be real soft, so there's not going to be much force if it was to hit the rim. It's not going to go further. Apply backspin on the ball. You want to do that, I mean, for several reasons. One, it keeps the ball stable. It gives you a little bit more lift, so you don't have to exert as much energy into the ball. But mainly in regards to this program, if you enable the backspin, it's not going to have as much velocity when it hits the ball coming backwards, so I mean it has more chance of going into the hoop. Alright, so let's see what happens. And I missed, so let's try to give it a bit more velocity. Alright, 2.1, 17, 55, let's say 15, and yes, I want to apply backspin. Sweet. So winning. I'm sure this program isn't completely error-proof. I'm sure you could probably exploit it if you wanted to, but there's the general gist of it, and I hope you enjoyed it somewhat.